students, we discussed the most important topic the examination point of view, relation between line and phase voltages and currents in a balanced system. Okay, in any three-phase source or load, in any three-phase AC source or load, there are three elements. There are three elements in it. Okay, the voltage across each element, the voltage across each element, the voltage across each element, that is nothing but each element in the sense phase, is called phase voltages. Is called phase voltages. And the voltage across the terminals, voltage across the element is nothing but the phase means voltage across the terminal, voltage across the terminal, voltage across the terminals which are connected to lines, which are connected to lines is called line voltage. Is called line voltage. Similarly, the current in elements is called the current in elements. Similarly, currents in the elements are nothing but phase. Currents in the elements are nothing but phase is called phase currents. Okay, and the current which goes from or comes to the terminals, the currents which goes from or comes to the terminals, to or from lines, is called line currents. Is called line currents. Okay, this system is obtained by joining together similar ends or either the start or the finish, because we are connecting the star connection. So let us consider a star connection here. Okay, so the same relation between the line, phase, voltage and expression for power in a balanced star connection. In case of balanced star connection, okay, so let me draw the circuit here. A winding like this. So this will be the R phase, will be having the ER, voltage of the R phase. This will be R, and this will be the Y phase, and this will be the B phase. RYB. So this will be the EY. If this is the neutral, all currents are leaving from the junction. Okay, this will be the RY, this is EB. So this will be nothing but a neutral wire. Okay, this is the connection diagram. Connection diagram of star connection. Three-phase star connected. Star connection diagram. Okay. By convention, the sequence RYB is taken as positive. So we have taken RYB, no, here, the clockwise direction. The sequence RYB is taken as a positive clockwise direction, whereas here RBY will be taken as a negative, Okay. The EMF induced in the three phases are shown vertically. Okay. In star connection, there are two windings between each pair of outers, and due to the joining of the similar ends together, the EMFs induced in them are in opposition. Okay, the potential difference between the two outers, known as the line voltage, and is a vector difference of the phase EMFs. So let me show you the line voltages and phase voltages relation here. So line voltages, and phase voltages relation here. Okay, line voltage and phase voltage relation. For example, let us consider the same circuit. Hmm, let me consider this point. Okay, let us name this as what we are. Let us name this as what VRY, VYB, VBR, VBR. So this is what one type of phasor diagram. If not, if you don't understand this point, let me also change this to another mode. Let us consider this as the so let us take this as what VR, or sometimes it is also called as ER. Let us fix here EY, because this is a clockwise direction. No, clockwise direction. So for that, so let us consider this point as EB. Now each angle will be what 120 degree here. Now to get the value of ERY, how do I get here? ERY, voltage across R and Y phase, line voltage R and Y phase is nothing but ER minus EY. This also can also be written as ER plus of minus EY. We already have ER phase, yes or no? To reduce the confusion, let me change this. Let me remove this VR. Okay. Okay, we already have ER value. We don't have any minus EY, but we have plus EY. So to get this minus EY, just elongate the line in a mirror image. Okay, this will be nothing but minus EY. So that value will be what? Minus EY. Now we have to find the relation between, we have to vector sum of EY and ER. For that reason, you take this phasor, this vector as a reference point. From this point, you join, you make this as a reference point, starting point. With the help of this, you draw a line parallel to ER. You draw a line parallel to this point. Okay, and with the help of with the reference of this point, you draw a line parallel to